This problem says Joe's rectangular garden is 6 meters long and 4 meters wide. So let's go ahead and make the rectangular garden 6 meters long and 4 meters wide. So there's a rectangle, and it's 6 by 4. I know this isn't really drawn to scale. He wishes to double the area of his garden by increasing its length and width by the same amount. So he wants, his area right now is 24. His current area is 24, and he wants his new area, we'll call it area sub n, to be double that, which is 48. So 48 is equal to, and he wants to double it by adding the same thing to both dimensions. So let's write a new formula for it. I'll write it like that. The new formula is going to be the new length, which is x plus 6, or 6 plus x, times the new width, which is x plus 4. So there's your expression that they asked for. It says just to write an expression for the new area, draw and label the diagram. So there's your answer, and then the next step might be to solve this for x, in which case if they did want you to take it to the next level, I'll go ahead and explain what you'd have to do for that. You'd have to multiply this out, put it in standard form, so it's x squared plus 6x plus 4x plus 24 equals 48, and then solve that equation for x by using either factoring or quadratic formula or the completing the square method. So let me write this up here and do that for you right now. So I'm going to set this equal to 0. You've got to always set your equation equal to 0 if you've got an x squared and an x term. So x squared plus 10x minus 24. And now if that can be factored, which it can, I would want to factor it. I'm going to factor this into x plus 12 times x minus 2, because you'll notice that if you multiply that back out, you'll see that that actually works. There's a inside plus the outside equals positive 10x, and then the last and the first equal what they need to equal. 12 times negative 2 is negative 24, x times x is x squared, and so that works. And then the zero product property says that since something times something else equals 0, the only way that that could happen is if this first thing equals 0 or the second factor equals 0. And so I've got now, instead of a long quadratic equation like I started with, I have two linear equations that I can now solve for x by getting x by itself. So x either equals negative 12 or positive 2. Now you'll notice that it can't be negative 12. That's not a rational, or that doesn't logically make sense because we're talking about lengths, but it can equal positive 2. And to check our answer, let's plug it back into the original. What's 2 plus 6 is 8, 2 plus 4 is 6, 8 times 6 is 48. So when I add 2 to both the length and the width of my original rectangle, instead of being 6 by 4, it becomes 8 by 6, and the area turns into 48 now. So that's, I went further than what they asked us to do, but you will eventually need to take it that far. So good luck.